$65 billion. That is the number the White House put on the table in March 2026, an emergency shipbuilding package, the largest naval construction surge since the Reagan-era 600-ship Navy. Enough money, on paper, to build dozens of frigates, unmanned surface vessels, and, most controversially, a return to conventional powered aircraft carriers alongside the troubled Ford-class nuclear program. $65 billion. And when the Pentagon briefed Congress, the slides were confident. New hulls, new classes, a fleet sized to match China ship for ship. Here is the problem. China does not need $65 billion to outbuild the United States Navy. China is already outbuilding the United States Navy. Right now. Today. By a ratio that should alarm every taxpayer funding this surge. In 2025 alone, Chinese shipyards launched more combat tonnage than every American shipyard combined delivered across the previous 3 years. The gap is not about ship quality or technology superiority. It is about one thing American shipyards lost 20 years ago and never replaced: workers. Congress will write the check. The question is whether America still has the industrial foundation to cash it. The math is worth walking through. The United States has 7 major shipyards capable of building combatant vessels. 7. For a Navy that operates across 2 oceans, 3 fleet concentrations, and 6 carrier strike groups simultaneously. Huntington Ingalls Industries in Newport News, Virginia, builds nuclear aircraft carriers and submarines. General Dynamics operates Bath Iron Works in Maine for destroyers, an electric boat in Groton, Connecticut for attack submarines. Austal USA in Mobile, Alabama, builds the Independence-class littoral combat ships and is tooling up for the Constellation-class frigates. Fincantieri Marinette Marine in Wisconsin is the lead yard for Constellation. A handful of smaller yards, including Bollinger, Eastern, and VT Halter Marine, handle patrol craft and auxiliaries. That is the entirety of American warship production capacity. 7 primary yards, roughly 42 active construction ways and dry docks between them, serving a Navy that wants to grow from 296 Battle Force ships to over 380 in the next 15 years. That is where the equation breaks. Those 7 yards are not waiting for work. They are drowning in it. Huntington Ingalls has a maintenance backlog on submarine overhauls stretching 3 years. The Virginia-class attack submarine program is running 24 to 36 months behind schedule per hull. The Ford-class carrier program consumed so much engineering bandwidth that the yard deferred maintenance contracts for Los Angeles-class boats that needed urgent reactor work. Bath Iron Works is delivering DDG-51 Flight 3. Arleigh Burke destroyers, an average of 14 months late per hull. The Constellation-class frigate, the program the Navy designed specifically to be cheap, simple, and fast to build, is already 2 years behind schedule before the lead ship has even entered the water. $65 billion does not fix a backlog. It adds to it. I spent hours going through workforce assessments from the Navy's own shipbuilding directorate, and one detail kept nagging me. The number 37,000. That is the estimated shortfall in skilled tradespeople across American shipyards, welders, pipe fitters, electricians, marine machinists. Not in 5 years. Right now. Today. As of the most recent industrial base assessment, 37,000 missing workers. In an industry where training a certified nuclear welder takes 4 to 6 years. In an economy where those workers can earn more in commercial construction, oil and gas, or data center build-outs without the security clearances and the commute to a shipyard. The Pentagon's $65 billion plan assumes those workers exist. They do not. And the comparison with China is not just uncomfortable, it is structural. China's shipbuilding workforce is estimated at roughly 600,000 workers across state-owned and commercial yards. The United States has approximately 95,000. China has expanded dry dock capacity by 40% since 2020. The United States has not built a new major dry dock since the Cold War ended. China can surge production across dozens of yards because their commercial shipbuilding sector, the largest on Earth by gross tonnage, provides a permanent training pipeline. A welder who builds container ships on Monday can build frigates on Friday. The skills are transferable. The workforce is elastic. In the United States, military shipbuilding exists in an isolated industrial silo. Welders who build destroyers in Bath, Maine, do not float between commercial and military contracts because there are no major commercial shipbuilding contracts. America stopped building commercial vessels decades ago. The workforce has no reservoir to draw from. Every new hull competes for the same fixed pool of certified workers. And when you add 30 new hulls to the pipeline without adding workers, the math produces one outcome: delays on every hull, across every yard, simultaneously. The Pentagon briefing slides left out one equation. At current production rates, American shipyards deliver roughly 9 to 11 combatant vessels per year. That includes submarines, destroyers, frigates, amphibious ships, and auxiliaries. China delivers between 15 and 20. The $65 billion surge would need to increase American output to at least 15 hulls per year just to maintain parity, not close the gap, but stop it from widening. That requires a roughly 50% increase in throughput from yards already running behind schedule, with a workforce already 37,000 people short. Run the numbers. Money is necessary, but it is not sufficient. The ambition behind this plan is correct. The problem is the gap between that ambition and the industrial base asked to execute it. The United States spent 30 years after the Cold War optimizing its shipyards for efficiency, not capacity. Every consolidation, every merger, every yard closure was driven by the same logic: do more with less. That logic works brilliantly in peacetime. It produces exactly the kind of fragile, single point of failure industrial base that collapses under surge demand. 3 decades of procurement policy treated shipyards as cost centers, not strategic assets. The fragility was the predictable result. So what does the $65 billion actually buy? The public plan breaks down roughly as follows: 12 to 15 Constellation-class frigates at approximately $1.2 billion per hull. Acceleration of the Virginia-class submarine program from 2 boats per year to a target of 2.5, which in practice means finishing the ones already behind schedule. 6 to 8 large unmanned surface vessels. 2 to 3 conventional powered aircraft carriers, a class that does not yet exist even on paper. Workforce development funding, and infrastructure upgrades across the yard network, including reactivation of mothballed facilities. Here's what each of those line items actually requires. The Constellation-class frigate was supposed to be the Navy's easy build. Based on the Italian Frem design from Fincantieri, it was selected specifically because it was mature, proven, and, in theory, simple to produce in American yards. The original timeline called for a lead ship delivery in 2026. That ship has not delivered. The program is roughly 26 months behind the original schedule. Weight growth forced redesigns. Integration of American combat systems, the Aegis baseline, the Spy-6 V3 radar, the Mark 41 vertical launch system, turned out to be substantially more complex than the Navy's cost estimates assumed. Every modification cascades. A heavier ship needs more structural steel. More steel changes the center of gravity. Changed gravity requires recalculated stability margins. Recalculated margins require updated damage control assessments. Updated assessments require new test protocols. One detail that stuck with me: the Navy originally sold the Constellation program to Congress as an $800 million ship. The current unit cost estimate has crossed $1.2 billion. That is a 50% increase before a single hull has been commissioned. And the $65 billion plan wants to build 12 to 15 of them. Multiply that overrun across the fleet buy, and a significant portion of the surge funding goes toward absorbing the gap between the promised price and the real one. That is bookkeeping, not shipbuilding. One piece of this plan looks counterintuitive at first, then makes sense once you understand the strategic geometry. The most controversial element of the shipbuilding surge is not the frigates, not the submarines, and not the unmanned vessels. It is the proposal to restart construction of conventional-powered aircraft carriers, ships driven by oil-fired boilers or gas turbines instead of nuclear reactors. The United States Navy has not operated a conventional carrier since USS Kitty Hawk was decommissioned in 2009. Every carrier built since Nimitz has been nuclear. Nuclear power gives a carrier functionally unlimited range, eliminates the need for fuel resupply at sea, and provides enormous electrical power for sensors, catapults, and, eventually, directed energy weapons. Why would the most powerful navy on Earth go backwards? Because nuclear carriers take 14 years to build, and the Navy cannot wait 14 years. The Ford-class program made this reality painfully clear. USS Gerald R. Ford was authorized in 2008. It was not commissioned until 2017, 9 years later. It did not deploy operationally until 2023, 15 years after authorization. The second ship, USS John F. Kennedy, was laid down in 2015 and is not expected to commission until 2026 at the earliest. 11 years. China commissioned 3 aircraft carriers in the time it took the United States to build one. The math is simple. A conventional carrier, something like a modernized Kitty Hawk design with gas turbine propulsion, could theoretically be built in 6 to 7 years. It would carry fewer aircraft. It would require fuel replenishment every 7 to 10 days of high-tempo operations. It would generate less electrical power for future weapon systems. Every operational metric would be inferior to a Ford-class nuclear carrier, and it would exist. That limitation is actually the point. A 6-year carrier that deploys in 2032 provides more deterrent value than a 14-year nuclear carrier that deploys in 2040. Because the threat is not in 2040. The threat is now. The math of deterrence is not about the best ship. It is about the ship that is present. And presence requires hulls in the water, not hulls on the planning board. Subscribe to Navy Strikeforce. We do not celebrate weapons. We calculate whether they work. Now, the plan has an even deeper layer, one the Pentagon has not publicly briefed, but that defense industry sources and congressional staffers have confirmed in outline. It is called Pacific Forge. The logic behind Pacific Forge starts with a simple admission. American shipyards cannot produce enough hulls fast enough, even with $65 billion, even with workforce development programs, even with reactivated dry docks. The industrial math does not close domestically, not in the timeline the strategic environment demands. So the plan proposes something the United States Navy has never done in modern history. Build sections of American warships in allied shipyards overseas. Japan's shipbuilding industry operates at world-class quality standards. Japan Marine United, Mitsubishi Heavy Industries, and Mitsui E&S build complex combatant vessels for the Japan Maritime Self-Defense Force, using processes and standards directly comparable to American military specifications. South Korea is even more capable. Hyundai Heavy Industries and Hanwha Ocean are among the largest and most efficient shipbuilders on the planet. South Korea builds Aegis-equipped destroyers, submarines, and amphibious ships for its own navy and for export customers. HD Hyundai alone has more dry dock capacity than all 7 major American military shipyards combined. Pacific Forge envisions a modular construction model. Hull sections, propulsion modules, and structural components would be fabricated in Japanese and South Korean yards, using American blueprints, American steel specifications, and American quality control oversight. Those modules would then be shipped to American yards for final assembly, combat system integration, and commissioning. The advantages are significant. Allied yards have the workforce. They have the dry dock capacity. They have decades of experience building complex warships. Modular construction allows work to proceed in parallel. Bow section in Yokohama, stern section in Ulsan, midship section in Bath. Final assembly takes a fraction of the time of building from keel up in a single congested yard. Here's the take that will probably get us pushback. Pacific Forge is the most strategically intelligent element of the entire $65 billion plan. And it is also the one most likely to be killed by politics before it ever produces a single hull section. Because it requires admitting something that no Pentagon official, no shipyard executive, and no member of Congress wants to say on the record. America cannot build its own Navy fast enough anymore. Not alone. Every shipyard in the United States is located in a congressional district. Every congressional district has a representative whose re-election depends on shipyard jobs. The political economy of American naval construction is built on the principle that warships are built in America by Americans in American yards. Jones Act requirements. Buy American provisions. Davis-Bacon prevailing wage rules. These are not obstacles to Pacific Forge. They are the legal architecture of American shipbuilding, and dismantling them requires legislative action that no member of Congress from a shipyard district will support voluntarily. The Pentagon knows this, which is why the classified version of Pacific Forge focuses not on hull construction, but on non-critical modular components. A bureaucratic formulation designed to thread the needle between strategic necessity and political reality. Build the modules overseas. Assemble them in America. Call the ship American-built. Everyone saves face. Whether that formulation survives contact with congressional committees remains to be seen. What do you think? Is building warship sections in Allied shipyards a practical solution, or does it cross a line that American industrial sovereignty should not cross? That question will likely define naval procurement policy for the next decade. There is another piece of this equation that the public discussion has almost entirely ignored. The $65 billion plan allocates roughly $4.2 billion for workforce development, training programs, apprenticeships, community college partnerships, shipyard modernization to make the work less physically punishing and more attractive to a generation that has options. $4.2 billion sounds substantial. Convert it to an equation. 37,000 missing workers. 4-year average training pipeline for a certified military shipyard welder. A starting wage at Huntington Ingalls of approximately $23 per hour. Competitive in Newport News, Virginia, but well below what the same worker could earn in Houston energy construction or Northern Virginia data center buildouts. The fully burdened cost of training one shipyard worker through a 4-year apprenticeship program, including wages, benefits, facilities, instructors, and attrition, runs approximately $250,000 to $350,000 per worker. Do the math. 37,000 workers at $300,000 average training cost equals roughly $11 billion. The plan allocates $4.2 billion. That closes roughly 12,000 of the 37,000 worker gap over 4 to 6 years. The workforce problem is not solved by the surge. It is reduced by about 1/3, and that assumes the trainees stay, which historically, roughly 30% do not. Shipyard apprenticeship attrition has hovered between 25 and 35% for the past decade. Workers complete the training, acquire the certification, and leave for higher-paying commercial work. The shipyard paid for their education. The private sector benefits from it. That number does not exist in peacetime labor economics. It is the signature of an industry competing for talent against sectors that offer more money, better conditions, and no security clearance requirements. There is one more variable that changes the equation entirely. and it is one the United States has not seriously considered since 1945. Reactivation of dormant shipyard infrastructure. The Philadelphia Naval Shipyard closed in 1996. At its peak during World War II, it employed over 40,000 workers and could launch a ship every 5 days. The dry docks are still there. The cranes are gone. The workforce dispersed 30 years ago. But the physical infrastructure, the basins, the waterfront, the rail connections, the proximity to the steel mills of Pennsylvania still exists. The $65 billion plan includes $1.8 billion for infrastructure, and Philadelphia is reportedly on the classified list of potential reactivation sites. But reactivating a shipyard is not installing new equipment in an empty building. It is rebuilding an entire industrial ecosystem: cranes, electrical systems, environmental remediation, workforce housing, transportation, supply chains, in a facility that has been idle for 3 decades. Pentagon analysts have modeled this scenario. A realistic timeline for bringing a mothballed yard like Philadelphia back to even partial production capacity is 8 to 10 years. And that assumes continuous funding, which assumes continuous political support, which assumes that the strategic threat from China remains at the top of every administration's priority list for a decade. That is 3 presidential terms. During a period when defense priorities shift with every election cycle. We told you in the video on the Ford carrier fire that the Navy's biggest vulnerability was not enemy missiles. It was the industrial base behind the fleet. What we showed you was the operational consequence of losing a carrier to mechanical failure. What we did not show you was the deeper problem, that replacing that carrier takes so long that the loss cannot be absorbed without strategic consequences. The $65 billion shipbuilding surge is the Pentagon's attempt to address that deeper problem. The honest assessment, based on the numbers, the workforce data, the yard capacity, and the political constraints, is that it addresses roughly half of it. Maybe. Here is the scale equation that matters. China currently operates approximately 370 battle force ships, including its Coast Guard and maritime militia vessels that would participate in any Taiwan contingency. The United States operates 296. The $65 billion surge, if fully executed, if workforce targets are met, if Pacific Forge survives congressional politics, if the Constellation program gets back on schedule, if conventional carriers move from concept to keel laying within 3 years, that surge closes the gap to approximately 340 American hulls versus a projected 420 Chinese hulls by 2035. 340 versus 420 after spending $65 billion. The gap narrows. It does not close. And here's the detail that makes this extraordinary. The cost per hull in Chinese shipyards averages roughly 60 to 70% of the cost in American yards, even accounting for lower labor costs and state subsidies. A Chinese Type 054B frigate costs approximately $400 million. A Constellation-class frigate costs $1.2 billion. Both carry comparable combat systems: phased array radar, vertical launch cells, anti-submarine warfare suites, helicopter facilities. 3-to-1 cost ratio in China's favor across every hull type. The United States is not losing the shipbuilding competition because it lacks money. It is losing because the industrial structure that converts money into warships has atrophied to the point where each dollar buys less capability, more slowly, than the adversary's dollar. That is an industrial policy problem, not a budget problem. And no single appropriation bill, not even a $65 billion one, solves an industrial policy problem without the industrial policy to go with it. We will say what most will not. The $65 billion headline is designed to signal resolve, not to solve the structural deficit. It is a political number attached to an industrial problem. The actual reforms that would close the gap: allied co-production at scale, commercial military shipyard integration, fundamental changes to acquisition timelines, are harder, slower, and less impressive in a press conference. But they are the only variables in this equation that change the outcome. Step back, and the more useful question is not whether America can outbuild China. It is whether it needs to. The United States Navy does not fight the same war. China's Navy is designed to fight. China is building a fleet optimized for the first island chain, the Taiwan Strait, the South China Sea, the East China Sea, short distances, dense coverage, home waters. The United States is building a fleet designed to project power across oceans, sustain operations for months at forward positions, and control sea lanes that connect the global economy. Those are not the same fleet. They should not be compared hull for hull any more than you would compare a Formula One car to a long-haul truck by counting wheels. But the political narrative demands a number, and the number is 65 billion. The first Constellation-class frigate is projected to commission no earlier than late 2027. The first conventional carrier concept study will not report findings until 2028 at the earliest. Pacific Forge, if it survives, would not produce its first modular hull section before 2030. Workforce development programs will not reach full capacity before 2031. The $65 billion surge begins delivering results in the early 2030s. The strategic window, the period when the risk of conflict over Taiwan is assessed as highest, runs from now through 2030. The money arrives after the danger peaks. That is the equation nobody in Washington wants to write on a whiteboard. The surge is real. The threat is real. And the timeline mismatch between them may be the most consequential gap in American defense planning since the missile gap of the 1950s, which, it is worth remembering, turned out to be largely fictional. This gap is not. Will the $65 billion shipbuilding surge actually close the gap with China? Or will the industrial base consume the money without producing the hulls? Comment yes or no. Every variable in this equation points to one conclusion. The United States cannot spend its way to naval superiority. It must build its way there. And building requires yards, workers, allies, and time. The $65 billion buys time. Whether it buys enough depends on decisions that have not been made yet, by leaders who have not been elected yet, in shipyards that do not yet have the workers to execute the plan. Subscribe to Navy Strikeforce, because what we just showed you is the equation nobody else is teaching. The most powerful Navy in human history is not running low on weapons, technology, or money. It is short on welders, and that is the variable that determines everything else.